Groundwater, flowing beneath the Earth's surface, has long been a crucial water source for humanity. An important advantage of groundwater is its consistent supply regardless of weather conditions, such as drought. Additionally, high mineral content and clean water quality are other notable benefits of groundwater. Even in the current era of significant advancements in water purification technology, groundwater still constitutes a substantial portion of about 35% of the world's water resources. As of 2022, approximately 50% of drinking water, 40% of agricultural water, and 30% of industrial water are sourced from groundwater. Moreover, groundwater is often utilized in local areas to produce drinking water or to extract for domestic purposes. However, groundwater is not exempt from resource depletion challenges. According to a joint study by NASA and the University of California, Irvine in 2015, some of humanity's primary groundwater sources have already reached levels of depletion that are categorized as unsustainable. Furthermore, if groundwater is depleted, it takes a significantly long time for it to be replenished to its original state, making the consequences of groundwater depletion extensive. The capital city of Indonesia, Jakarta, dubbed the fastest sinking city in the world, plans to relocate due to rampant groundwater usage causing land subsidence. Recently, a study revealed that excessive groundwater extraction has even caused a shift in Earth's axis of rotation. Not only the shifting of Earth's axis, but also the potential impact on climate change due to excessive groundwater extraction has added to the shock. In the past 100 years, the Earth's axis of rotation has shifted by about 15 meters. Even in the absence of external factors, the Earth's axis of rotation naturally undergoes shifts during its rotation. Due to airflow changes such as the difference between low and high-pressure systems, the Earth's axis shifts by about 2 to 3 meters annually. However, in the 21st century, it has been discovered that the Earth's axial movement has shifted in an unexplained direction. Although scientists have had trouble uncovering the cause of this shift, Seoul National University's research has recently revealed that artificial influences could alter the Earth's axial movement, as indicated by their study findings. The research team from Seoul National University compared groundwater usage from 1993 to 2010 with various factors influencing sea level rise. Using geodetic methods like QZSS, the team measured Earth's axial shifts and movements. VLBI, Very Long Baseline Interferometry, technology plays a crucial role in obtaining highly precise observations of Earth's axial changes down to millimeter levels. The team's analysis of sea level rise factors included natural, artificial influences, and groundwater depletion. Results indicated that besides Greenland and Antarctic ice sheets, groundwater inflow could cause a sea level rise of up to 6 millimeters. Using groundwater usage over the same period, the team calculated actual sea level rise. Subsequently, the research team calculated the actual sea level rise based on groundwater usage during the same period. From 1993 to 2010, humanity used about 2,150 gigatons of groundwater. This amount could fill over 860 million Olympic-sized pools and have some remaining. Extracted groundwater like this mostly flows along rivers to the sea after its use. Global sea level rise has been attributed to the groundwater that flows into the oceans, resulting in a shift in Earth's mass distribution, as explained. The research team simulated the extent to which each factor influences Earth's axial movement, revealing astonishing findings. The simulated and actual axial movement directions were remarkably similar due to the impact of human groundwater usage. In contrast, the simulation results without considering groundwater influence and the actual axial movement direction exhibited a significantly large discrepancy. As evident from the image, simulations considering groundwater influence align better with the actual axial shift of Earth, as depicted. Earth's axis shifted by about 78.48 centimeters toward longitude 64.16 degrees east, averaging 4.36 centimeters per year. Based on these findings, the research team concluded that human groundwater usage acted as a factor in shifting Earth's axis on a global scale. Of course, the value of around 80 centimeters may seem very small compared to the naturally occurring shift of 15 meters. However, what we should take note of is the fact that human-induced actions can have a significant impact on the global climate change as a whole. For example, the Northern Hemisphere currently has winter at perihelion, its closest point to the Sun, and summer at aphelion, its farthest point from the Sun. If the axis shifted by about 180 degrees due to factors like groundwater depletion, the Northern Hemisphere would have summer at perihelion, its closest point to the Sun, and winter at aphelion, its farthest point from the Sun. In summary, this means hotter summers and colder winters, creating a much larger seasonal temperature difference. The substantial energy imbalance between summer and winter could result in extreme climatic events, such as super typhoons, that would be difficult for humans to handle. Indeed, reckless groundwater depletion is not only limited to a water scarcity issue but also has the potential to impact the entire global climate. It's a highly significant concern that extends beyond water shortages. Humanity has rapidly progressed by indiscriminately exploiting Earth's resources up to now. As a consequence, we are now facing numerous climate issues right in front of us. Will humanity really perish without resolving these climate issues? Or will we experience another wave of advancement through a technological revolution, overcoming these challenges?